Hi, I'm Dave Robinson, and welcome to another screencast we'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, an amazing weekly data project in R run by the R for Data Science online learning community. And as usual, I'm joining you live, and so if you write into that chat box, I'm actually able to see what you're typing. I'm really interested to hear what people interested to see people's questions, ideas for visualizations. It's one of my favorite parts of doing this is doing this live and engaging with the audience. So if you've if you're able to, so definitely say hi. If you can see me. And yeah, let's get, because last week I discovered that or 2 weeks ago when I did the last screencast, I discovered that only a few minutes in that I wasn't broadcasting. But yeah, let's get started with this week. So this week we're going to look at the Lego dataset. Now, generally this is data that I've never looked at before. I do remember doing an analysis of this once a couple years ago, not live, I think. So it's not completely new to me, but it's been a long time since I took a look at this data. This is data from, let's see, the Lego parts, sets, colors, and inventories of every official Lego set in the Rebrickable database. So it looks like we got 3 sets here: inventories, inventory sets, and sets. And I'm going to use Tidy. So I'm going to go over to R and use Tidy template to create a file from today's data. And I'm going to just use, here we go. Whoop, that's a problem. It's all right. That's not. There seems to be a problem with the with downloading it. So I'm gonna go ahead and read it in manually. Here we go. We have inventories, inventory sets, and sets. All right. So let's see what we got. Inventories, an ID, a version, a set. That's not too not too exciting, I suppose. Well, at least we have. Let me see. I guess the idea there of inventories is to say, okay, some of these have multiple versions, so we can get like a set ID, a version, and a set number. So some of them, like this one, has 16 versions of this set. All right, and now let's look at inventory sets. All right, so that links set num to an inventory ID, and now let's see. Oh, so inventory, and that would be. Let's see. I'm taking a quick look at this. Let's first look at sets and then bring some of the other ones in. All right, now we have set numbers, and we say like, okay, this year, this theme. Yeah, but I don't have things like. I wonder where's the theme, I wonder? Let's see if we can download maybe let's download a bit more data, and you can use the API. The files are updated daily. All right, let's take a look at this. Oh, okay, so there's actually a couple more files we can use. Let's go ahead and grab all of them. So how would we go about doing that? Let's see, we have all these files. There's a tool for bulk downloading, but I don't think I have it set up. Let's go ahead and just click all of them. So, because we have 3 in Tidy Tuesday, but maybe we want to grab a whole bunch more. Yeah, these aren't too. These really weren't that slow. And let's do downloads and Legos. Here we go. All right, let's put it in, and yeah, we could do. Okay, let's actually try. Let's actually unwrap. I could just click on all of them, but let's go ahead and unwrap them read them in here. So what I do is say, let's see, move downloads Legos to here, and now I'll do. I can do dir of Legos, that lists all the files, and I do full names is true. Now I'd map read CSV to them, and I think, yep, read, there we go. Check that out. So now that actually gives each of these a name, and I can't remember, how do I do map with the names? I want to keep like the names of the files. Yeah, I'm gonna go ahead and just do this. I'm gonna do Lego files is this, and then say Lego files map read CSV set names to Lego files, and Lego files I'm going to go ahead and actually I'll do this a little bit differently. Here's a trick that I really like. I say file is this, then I say data is map file read CSV. And I can actually, the nice thing I like about this is that now I can do an extract the file. I can pull out the Lego / something .csv.gz into a new column called, give myself a second, into a new column, oh shoot, let me see, yeah, called name, and dot remove equals false, dot, no, it's not remove. Well, I can do it this way actually, then I don't need to, file read CSV, must be a vector, oh, I missed a pipe. That was what's going on. All right, so so now I've got my colors and my data, and then I can, I just like it because I can use extract really easily to pull this out. And check this out. Now, here's a fun one. Deframe from Tibble turns it into a list. Aha, pretty cool. All right, so files. So what I did is I read all of them in. I pulled out the part of the name that I cared about, and then I deframed it, which means turning it into a list where I can now say, actually I'm going to call it Lego datasets. And now I can say Lego dataset colors, Lego datasets elements, Lego datasets, look at that, look at it go, inventory parts, and so on. All right, so now we've got the, we read in all the data sets. Let's talk about one of the first ones, which is sets. All right, so data sets. All right, what might I want to know about sets? Well, the simple thing I might want to know is over what period of time are we working with. So I might do something like a histogram on year. Yeah, so we're looking at most are in the last 20 years, but they go back all the way to maybe the late 1940s. I could have visualized this instead as a count year yeah, I just like it because then so now I can say year, it says year, number of sets of Lego sets, you know, get along those lines. I'm going to do a couple other things. There's theme set, theme light. I'm going to load in the scales package. All right, so now I've got this, all right, so now I'm able to say something like, okay, Lego sets over time. Let's look at a few other things that we might use here. One is I might use, let's see, we've got sets. Some have the same name. Like basic building set pops up many times. I'm actually going to do a group by name, summarize, and sets is N, and then, you know, I didn't really talk yet about Legos themselves, but I like Legos growing up. I wouldn't say like I'm a Lego fanatic, but I do really like the Lego movie. Big fan of the Lego movie, and Where My Pants Guys is based on the Lego character from the Lego movie, a bit joke in the Lego movie. So that's pretty cool. And now, so now I can look at something like, okay, the number of sets in here in this set, and I can also say year first, min year, when's the first one? So, not in the range, but in the year first, min year, and I could also do something like year last, max year. I just want to understand, like, okay, all right, the basic build set, there have been 57 between 1968 and 2000. Fire truck, there have been 18 between 1970 and 2020. And if I just took a quick look at this, like, do they make sense? Okay, helicopter, basic set, fire station, fire truck. Those make basic sense, the kind of thing that we might see. We have Batman, a lot just named Batman or Millennium Falcon. All right, so just looking a little bit at like what some of the most common set names are. But let's I have oh, there it is. There, okay. And but I kind of like the look of this theme. So I'm noticing there's okay, a couple things about theme. There's a theme ID and then there's a name. So the name would, so like the theme name. So what I can do is actually take my sets, and I can left join. I could use inner join, but I'm going to try out a left join on with themes by theme ID equals ID. Oh, nope. Yeah, that's right. So now I've added my themes, but I'm gonna add a name, and I'm gonna actually do a bit of a rename in here and say ID and theme name equals name. So now I've got the theme name. So I can actually say like, here you go, theme. So now I've got sets, but I brought in a theme, the theme names. Now, is there anything else I might want to bring in to sets? Besides that, let's see what other things I have. I have sets. I have parts. Ooh, I'm gonna have a great time with that. Ooh, relationships between parts. This is gonna be fancy. I don't know what mini figures maybe is, but yeah. Then I got inventory sets, inventory parts, lots of things, lots and lots of things. I wonder what elements is, elements and parts. Ooh, so many fun things we got going on. Where does color come into this? I mean, I wonder. I think. Oh yeah, we're gonna take a look at the relationships, but let's look at that in a bit. Let's not look at that yet. So yeah. So now I'm taking a look at the themes, and the reason I like looking at it with themes is now I can do count theme name, or I can do so yeah. So one thing I could just do is say what are the most popular themes. Where I'll say head 12 and theme name. One of my favorite visualizations. Throw in a theme name is FCT reorder theme name by N. I want to get a bar plot where we can look at the top 12, or heck, let's make it 20 themes. I don't need a y-axis here, so I'll just do y is blank. All right. So I'll say most popular themes. Most common Lego themes. Let's look at the top 30. Gear, Star Wars, Technic, Keychain, Friends, Books, Basic. 30 is too many. It's too crowded. I did 25. And yeah, we can. So okay, so we get some sense of like, okay, here are the most popular ones, and man, there are yeah, a lot of some of these are real popular. Interesting to me that like I would have expected Batman, for example, to be somewhere in here. Let's try looking at the top 50. Do we see Batman? Or is it going to be in some subcategory like DC? I don't really see it. Huh. So here I was going to be like, oh yeah, this. There's Batman. I found him. All right. But yeah, we can start with our 25. All right. So let's take another look. Let's take num parts. Num parts. That's pretty cool. I like how we can join it, because then I can do sets with themes. Oh, oops. Because now I can do something like group by theme name, summarize n sets, median parts. I'm interested in like, there's some data might be bad here. Because notice what's going on with gear. There's so many sets and the median has 0. No way. Something's up with these zeros. So let's do filter num parts is 0. Looks like there are 3,000 sets out of 20,000 that have num parts 0. So I think that's some not great data. I don't know what why it's popping up with 0 and not NA. But let's go ahead and in this sets with themes do a mutate num parts. NA if is fun. I can say code this value as NA. It's like a it's a little more compact than an if else. And then when I do the median, I do NA RM equals true. NAF, tell your friends. So now we can say something like, all right, the median gear set has 15 parts, the median Star Wars set 148. Wow. And so then if I just look at something like filter for n sets is greater than 50, which is, no, I'm going to do it here. 81, that's too many. I can do something like n sets median parts and get a visualization showing the relationship. Is there a relationship? Do you want to put the accent on log scale? So what I was interested in here was like, what are the outliers in terms of what are common sets that have a lot of parts? I'm putting the y-axis on log scale too. The ones are a little bit, I don't know about these ones, but I know that I want to find out what some of these sets are. So I can do something like geom text label is name. H just is 1, V just is 1, and this is a nice trick. Check overlap equals true. So this will show, not name, theme name. So this will show like by theme. There's keychains, that makes some sense. Keychains have only one part, presumably, I suppose. And there are, on the other hand, Star Wars, City, I'm going to set a higher threshold, there's too many. Creator 3 and 1, there are some like, 75. Just trying to get like a sense of, trying to see that I have enough text for this. Like Minecraft tends to be pretty complicated. Keychain tends to be pretty simple, and I'm realizing that putting in a scatter plot might be more trouble than it's worth. So I'm going to go ahead and call this by theme. I like to call variables based on their what they're aggregating by. So I'm going to say by theme head 20. 25 is the ones with the most sets, and just do median parts. Very similar to one we had before, but I'm gonna flip them. Here we go. And now say like, all right, these are, what are the most complex? Sets. Themes. So Harry Potter tends to be complicated. Creator 3 and 1. It's interesting that Basic and City have a high median number of parts, but they've got like supplemental books, sure, and Keychain is at the bottom. So these are among the top, among the 25 most themes with the most sets. So this is one way to visualize it. But it's so now let me do a quick, yeah. So it's the most and least complex themes. Maybe I want to understand more about the distribution. So if I did that, what I'd want to do is not aggregate it by theme. I'd want to take sets with themes. Here's a trick I like. Filter FCT lump of theme name is 25 is not equal to other. This ensures, this gets me the same top 25. FCT lump takes all the uncommon ones and puts them in, calls them other. And then I can do a box plot where I say n num parts theme name, box plot. I haven't reordered it yet. It's not going to look as good as it is about to. Theme name is FCT reorder. Theme name by num parts. By default, it'll be the median, which suits me down to the ground, but I do need to tell it NARM equals true. Yes. All right, so this gets at our median being 1, but not necessarily all of them being 1. There's something I like about this. What are some of the things I like about this? I like that the monthly mini model build, whatever that theme is, presumably it comes out every month. It's pretty restricted. It has at least 10 parts, no more than 100 parts. I think it's maybe meant to some kind of like, oh yeah, every month send out this set. On the other hand, we have sets like Ninjago that can vary from 1 piece to thousands of pieces. So notice that that logarithmic scale. I like this graph. I'm going to polish it a little bit. I'll give it the same I'll give it the same title and subtitle as the earlier graph. Yeah, there we go. Only 25 themes with the most sets. So we get to see some things about about both the median and the distribution. So notice the log scale means like, wow, Harry Potter on average has more than 100 parts, but some like town, they're variable. All right. So these are some things in terms of number of parts. Those are pretty. That's pretty interesting. Another thing I might be interested in. So looking at sets. Another thing I might be interested in terms of complexity is, have they been getting more complicated over time? Not looking at themes now, but if I do my Lego data sets, I can just use sets with themes. It should be about the same kind of data. I can group by decade, and I like doing floor, year. Is it this? And that's not it. Oh yeah, no, it is. Just need 10 times. All right, so yeah, this is floor division. So it would say like, oh wait, I don't even need the floor, do I? Yes, this is what I was thinking of. Year, %/% divided by 10, floor multiplied by 10, and yeah, you've got a and now yeah, we've got a decade. So I can group it, and I can say n sets is n. Median num parts is median num parts. NARM is true. So it's not quite as simple. So one thing is, the 5 sets in the 1940s had a median of 142, and that it's always been smaller since. Maybe within a particular theme it's been changing, but there's no evidence of like getting more complicated over time. Let's do a box plot where I do something like mutate decade num parts scale geom box plot scale y log 10. And when you do a numeric x-axis, you need group equals decade. Look at that. Yeah, all this funky monkey variation. We have like 1940s, 50s, 60s. You know, when I have something like this where the number might differ, sometimes what you can do is add a geom jitter. And height equals 0, width equals 0.2. Now this is going to be too much data. Width equals 0.5. Width equals 1. What is going on here? Oh, it's by, yeah, no, I get it. Width equals 3. It's by decade, so it's by like 3 years variation. Yeah, so, and then if I add an alpha, too transparent maybe, but yeah, I kind of get a sense of like, okay, there aren't a lot of them here, and then there are more and more, maybe even do a little darker. Yeah, that gives a sense of like, are they getting more complicated over time? Not really. Not really. Like, there's just so much variation. Maybe we could look within theme, and are they getting more complicated over time? I'm not sure. I need to dig. I'm feeling the urge to dig into that right now. Yeah, Yeah, it could say something like our Batman one's getting more complicated over time. Actually, let's go for that. I like actually. Yeah, what did I say the most common ones were? Theme, sort. Sets with themes, count theme name. Star Wars. Our Star Wars one's getting more complicated over time. I like Star Wars, so we'll do. What do I say? Theme name. And the answer is no. The ones that were coming out in the 90s, the 2000s, then yeah, they weren't. They were already kind of as complicated as they are, on average, as complicated as they are today. All right. So let's look at a little bit at change over time. What do we want to look at next? Any suggestions from the audience? I've got one or two ideas. I'm pretty interested in colors, common colors. Colors associated with themes, colors appearing together in sets, like clustering of colors. Let's take a look for inspiration. Let's take a look at one of my Lego data sets. We looked at we could look at parts. We could look at materials. I'm a little less excited about materials. So materials is like then I'm really excited about colors. I think color, I feels like color makes certain kind of sense to me, where I'd say, ooh, wow, look at relationships, part categories. Wow, this is an adventure. Woohoo. We could look at part categories, which, like there are bricks, there are containers, there are probably other, what is, actually let's find out what other kinds of part categories there are. I bet figurines is probably one of them, something like that. Minifigs, there we are. Pneumatics, the wheels and tires. A lot we can look at here. We could pick two themes and try asking how they differ. If people have particular, so definitely in the chat, let me know if you have like themes that you're interested in digging into. I'd love to dig into Batman. I like Batman. I like Star Wars. What were some of the others? I don't know much about Ninjago, but let's see. Where was my popular, most least complex themes? Star Wars looks pretty good, and there are a lot of them. Could do Star Wars versus Batman or something like that. Question is, does the data show prices? I haven't seen prices yet. No, I haven't seen prices yet. I have an inventory parts and a color ID. Ooh, I like how many things I'm gonna have to join to get to the color elements to color ID. Wow, and then finally link back to color. All right. Yeah, I think let's try looking at color, and that'll be fun. There's so many ways to customize that. All right, let's talk about color. But first, we're gonna have to look at this plot a bit of how do these link to each other. So it looks like sets link into inventories. Looks like by what? By set num? By set num? Ah, yes, it does. We've been looking at the sets column. Actually, I'm gonna look at sets with themes. It's got a set num, and we can link that into inventories. Now we go down a separate minifigs path. But that can link into inventory parts, which links into colors. We might want to use the DM package today, which would be really fun. I'm going to save that as a treat. We can try using the DM package to kind of represent these relationships. It's been a while since I used it, so I might need to refresh myself. But let's start by just joining this. So, okay, what are we going to join on? We're going to join sets to inventories. I think there are multiple inventories within a set. Is that right? So let's see. Sets with themes. Lego data sets, inventories. So there's multiple. All right. So one thing is there can be multiple versions for each set num. So I'm going to arrange descending version and distinct set num dot keep all equals true. So here I get only the most recent. So inventories. These are the most recent, so I'll call this inventories current, most recent version of each inventory for each set. And then we, let's see, and then we link that to inventory parts. Wait, I did inventories. No, wait, yeah, that, okay. Set num is in here, so I can say set num to inventory, and then we have inventory parts, and that has a color ID. Okay, that's not too bad, because what I want to do is I take my sets with, I'm kind of building up in my head as well as out on the paper there, my idea of how am I going to link these together, and what I do is I do it 2 steps. One is a join on inventories current. 19798. Does it change if I join it? If I enter join it? No, that's good news. It means there's 1-to-1. There's no sets without an inventory. There's no inventories without a set. Or there's no multiple inventories to one set or anything like that. It's okay. We have a 1-to-1 set num, and then we join. So that's the inventories current. Lego datasets inventory parts. And that we have to join by, I'm going to do a rename. I don't like that it's called ID right now. I'll do an inventory ID equals ID. This just makes it a little easier for me to say inventory is current. And I actually only need this and the set num. So now it's just inventories are just links between sets and inventories. I feel like they had that somewhere. Well, the key is that I can now I can by inventory ID, and now it expands outward. So sets with themes, suffix. Oh, nope, I did this wrong. Image URL inventory, just wanted to give it its own name. This one can stay under image inventory. Okay, this is now, we have set, name, we have a theme, and critically though we have we're now of 921,000. We were looking before at 19,000 sets. Now we have 921,000 parts. And now we can actually say, we can start linking them together. We can actually say something like, here we go, I'm going to say set parts. And there's one more join here, which is I got a color ID. And I've got inventories, Lego datasets, colors, and I can link this in. So I can do, I'm going to do a left join by color ID equals ID, suffix is, I like it as a what do you call it? I like it as a prefix more than a suffix. So I'm going to do color name equals name. I'm even just going to call it color. Yeah, how about that? Now we can say, okay, I've got because I don't need the color ID, I just got a color. All right, this is pretty swell because why is it swell? Because I can find out what are the most common colors in history. So I can just do count color and throw in RGB, sort of goes true. And I would say black is the most common color. And oh, let me do one more thing to color. Let me do because I think I'm going to need it in a minute. RGB equals paste 0% with RGB. I think I'm going to need that in a minute. I just like to get this set up. So you see black, white, light bluish gray, dark bluish gray, red, yellow, blue. Okay, we can see the most common colors. Now if I'm going to visualize this, I probably want to do, I'm going to lump them. And I need to lump both of them together. So I would say lump color 16. RGB equals FCT lump color 16. Why not? Why 16? Why not? And now I've got n color geom call. You know what I'm going to do next, right? I would do an FCT reorder color n and say, okay. But you know, I don't know about you, but I am dissatisfied with this number of parts with this color. I am it was the most common parts, not necessarily the most common sets or anything like that that contain it. So I am going. Oh wait, and actually one thing I didn't check is there's a quantity, isn't there? Somewhere there's a quantity. I'm gonna have to work on that. Okay, we'll get back to that. I'm dissatisfied because all these bars are the same color, and I want to know what is the color of each of these. Well, what I would do is two things. Well, I'm gonna have to deal with the other in a second. I'm gonna deal with that later. I think I can do something like this. I can't, interestingly enough, do color equals RGB. That will just create a scale, or a fill equals RGB. That will create a scale where, nope, that's black, not black, that's not blue. I think this might work. I do, yes, great. This did work, but the problem was there was an other, which I'm gonna say filter RGB color is not equal to other, and then in a minute we're gonna deal with other correctly. Oh, fill equals, I thought the way it worked was we did fill equals I of RGB. Oh, oops. Haha, yes! So the I is this step where I'm actually saying, like we're saying, take it literally. It's a base R function where it says like as is, take it as is, and it's great that ggplot just lets us use that to customize it. It's been a while since I used the trick, so it's nice to see that it still works. I'm gonna add a color of light gray. I want outlines of these. Like, I don't like how that looks, so I'm gonna get rid of it. So the key is like, okay, we have white, we have transparent / clear, which is like also white-ish, and orange, lime. Those common colors. Check that out. This is pretty rad. So, all right. So now we can look at oh, and now we can include the other. If we want, we just need to give it a better lump. So we can say something like the other level is going to be, what's let me see. I can actually just write one. Other level is, I think I can just say gray, but it's frustrating. No, something's not oh. Right, there's kind of a thing here. I don't. Yeah, I think there's like. I'm just gonna ignore it. This is a perfectly good graph. All right. So the one thought is this graph might look better with a different background. It's been a while since I did GG themes. We're gonna do dark. I thought there was a theme for. I thought there was a theme for like theme dark. This one dark? I don't know. Anyone have a suggestion with a dark mode for this? Not sure, but yeah. So now we see. You could also do, I think, something like theme back. It's something like this. Background. I don't remember. I always forget how to do that. How to set a background color. If someone wants to help me out in the chat, go for it. But yeah, the main thing is that we can get this this kind of visualization. So I would really like to look at this. I like to look at this over time. And oh, what happened if I just did? Well, all right. Let's do this. Let's count by theme and the others. Oh, theme name. And now I can say something like, let's pick a couple of themes where I can say and let's say theme name is in Star Wars, Batman. Let's pick some really other popular ones. Harry Potter and let's say I was looking just a second at a bunch top ones. Let's say Christmas. Christmas, that's fun. I bet these are gonna have different color schemes. So let's do filter. Color is not equal to other. Ooh, somebody shared. Can I just do theme dark? It's like it's built in. Oh, of course, it's not in GG themes. Just yeah, there we go. I don't know if I like. It's plausible. We can go either way. All right. What I was saying was, imagine I've got this by theme now, and now I can actually apply this really a very similar graph. I'm gonna have to mess with this a little bit, but do facet wrap by theme name. And scales equals. So now we can look at something like, okay, what are the most popular within each theme, and how does the palette differ between these themes? But they're not. Notice they're not ordered right. So so what I'm actually going to try doing now, it's not terrible, this kind of ordering where we have it. Let me try this with theme dark. You know, that's pretty good. I don't know. Maybe. I could go either way on this. There's a few other ways we can do this visualization, but yeah, check. So like an example we can see between these is like Harry Potter doesn't use a lot of blue, Star Wars does. Christmas uses a lot of red, a lot of green, but now that so like here it's kind of fingerprinting them and putting them always in the same order. That is one approach. An alternative approach is here. Where am I? I'm gonna say. Let me see. Yeah, an alternative approach is I sort them within each of these. So the way to do that would be to say you take color equals reorder within. I haven't loaded the right package yet. Color and theme name, and reorder within comes from tidy text. Tidy text, you need to build a lot of plots that look a lot like this. And I need one other step to do a reorder rename, which is scale Y reordered. And scale. Very importantly, we need a free. Here we go. This is reordered, and we're showing all of them. We have an option here. I think I might prefer to do legend theme. Axis text Y is element blank to get rid of the text. Axis text Y is blank. That didn't work. Oh, because it was after the theme dark. No, this is one way to do it. I'm not so sure about the theme dark. Look at this. So now, like, yeah, the white is still a little bit confusing, I think. Christmas, for instance, has white at the top, and then red, then black. So red is really popular, and green is way higher than it is on the others. So there's some things that definitely make sense. What happened if I did 20 colors instead of 16? Does it look? I don't know if it looks better. If it looks, I don't know. I think it's pretty cool. So like here we can say, okay, Harry Potter uses a lot of black, and then a lot of kind of this beige, black. Yeah, you can kind of like see these this color scheme. That's pretty cool. All right, all right, so there's a lot of ways we can take this visualization now. One is that I might say by theme color. One thing we can do is say, let's instead plot it as n theme name fill equals color, but stack them. Oops, fill equals I color. Color, oh, nope, RGB. And now there's a trick for this. I can't remember what it is. It's I want them all to add up to 1. Shoot, it's stat equals geom call stat. There's a thing for this where I can say I want a spinogram that adds up. Stat, 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 stat. I know I'm using stat. Stat total. Prop. Nope. Stat, nope. Stat equals, can't find stat called prop, and here's one, geom bar, there's a geom text. After, see, I really thought that was gonna work. Oh well. I have my own way I can do this, which is group by theme name, mutate, PCT is n over sum n. There is a different way. That's why I'm a little hesitant here. I just can't remember what it is. Do a PCT. And you know I'm going to do a reorder within is actually, I think, still going to work here. Where I'm going to say, it does not, it's not going to work. Okay, because I had to do it on RGB. That's no good. Yeah, so I can't do a reorder within. That's okay. This is still pretty, like, this is still kind of compelling. And now instead of doing the just filtering for just these 4, I can say filter FCT lump of theme name 10, 16. And get rid of the other color. Here we go. So, yep, yeah, all right. One thing I haven't done here is there any kind of sorting. There are certain kinds of sorting that we could do that would kind of like put similar ones together. But yeah, we can say percentage of parts in this theme. So now we can take a look and see, like, okay, so it's not in any particular order. And say something like, all right, basic set use a lot of blue. Harry Potter doesn't use blue. Who uses the most green? Creator uses green. I don't know. Christmas uses green. Trains use kind of a normal set. Jungle, some green, some gray. Technic uses a lot of black. Yeah, we can see a lot of things here. What happens if I pull it out to 25? This is pretty fun. I don't know about you, but I'm having fun with this color question. Let's make it 40. Can I get Batman at 30? No, 30. And can I get Batman in there? Where's Batman? Batman's in there, but it's no good. It's a bad plot. Okay, so the yeah, this is one approach, and one thing we actually can do is do a bit of clustering here, where we can say, remember, I've got this by theme color and all these numbers. I can try saying how correlated are, how similar are pairs of themes, and by doing that, I do library YDR, which has YDR is a bit of a bug in it that I need to fix on CRAN. That's one of my packages, and it's going to warn me about it. But pairwise correlation of theme name by color based on n, and try. Uh-oh. Oh yeah, I didn't like that it was a factor. That's okay. We can get around that. So, yeah, but I need to do... Okay, what if I only said theme, FCT reorder... Oh, sorry, FCT lump, only the most popular themes. Theme name, 16. All right. This is saying, what are similar pairs of colors? And who has the colors that are most and least similar to a particular one? What if I said, what are the most... instead of 16, I'm going to do 50. And what if I say, okay, this is saying Ultimate Collector Series and Star Wars have really similar color palettes. So does City and Collect Creator 3 and 1. So much so that I might actually, realizing now the n's are kind of numeric, so I might actually want to do n equals log 2 of n. It doesn't matter if it's log 2 or log what, but okay, that might just like make a little more sense. So this is trying to say what are, so now I can say something like, okay, if I say what are the most similar, and this is saying how similar are their color palettes in terms of are these two close to each other? And I can say like item 1 is equal to Batman. Keep going back to Batman. So what I like about this is it shows, all right, the thing most similar to Batman is the Lego Batman movie. Makes sense. Very similar palette in the Lego Batman movie. Then Teenage Mutant Ninja Turtles, Ninjago the movie, City, Monkey Kid, Juniors. What is the least similar? Is Christmas the least similar to Batman? No, the service packs are least similar to Batman. And the Lego Movie 2 is not similar to even though, wait, no, sorry, Lego Movie 2 is up at the top. Service pack, some of these are less similar. Star Wars is not that similar to Batman. There's a bunch that are quite similar. Batman is similar to Justice League. It's a neat little mechanism of clustering. You see, we're clustering color themes based on their color palette. Most similar, yeah. Nifty. All right. Ooh, somebody told me fix me up on I don't need to do this if. Is it, let's find out. Can I get rid of this group and mutate? Somebody pointed out if I say position equals fill, is that what I was looking for? And yes, thank you. Thanks to Matthias for that fix. I forgot about position equals fill. Just made it a little bit easier. Same visualization. All right, we've been looking at the palettes. Oh, one last one. Somebody had earlier said colors over time, and we hadn't yet looked at that one. So let's, what's great about this is we actually can do like kind of the exact same. We're going to do something like, oh, I'm actually just going to say here color by year color and say color equals NA if color other. Remember NA if? All right, and so now just get those NAs in there. Let's see if it's too common, then we know. But let's try this. Let's try doing year. Let's do decade. We did this earlier. Decade and very similar to the previous one, but we're doing a plot over time. There's a name for the, oh, there's like an area. It's an area plot. Oh, I might even use an area. I meant to do this. And all right, the NAs are kind of getting on my nerves right now, because the NAs are at the bottom, which I don't care for. What happens if I just do filter? Sure, yeah. Let's go with that. I don't love how white is at the bottom because that it makes it hard to read. What if I said scale fill discrete reverse equals true? I think that's the one. Ugh. Nope, that's not even close to it. I don't know how to flip the fill. Yeah, that just isn't working. I don't know how to turn that literal into something. Okay, so wow, though I really like this this visualization. What if I did 25 colors instead of just 20? I can kind of just add, right? Like, what's stopping me? And why do I have to lump it all? That's the stuff. Whew. Ooh, somebody help me out. This is, yes, great. Position, fill, reverse equals true. Thank you, Dave Bress. Yes! That's the stuff. All right. So so this is, let's instead of doing a geom call, let's do geom area. That looks terrible. Oh, but because I need to do complete. Haha! Yes! Yes, and what if I made it every 5 years? This might be getting a little too noisy. With 2 years? I don't know, I might actually like it. It's spikier, but it kind of gets the vibe across, doesn't it? Yeah, okay. I can't put borders on the fill because some of these are like really finely grained, and the borders would cover it up. But yeah, what we're seeing here. Let's polish this up because I'm a big fan of this. X is year, Y is percentage of parts with this color. Scale, Y continuous labels equals percent. Format, this is pretty good. And let's do a theme minimal. Yeah, I think that's a little closer to like the other one had too many graphs, and I'm actually going to add even more theme. I don't need lines at all. Axis. What's the word for this? Panel, grid, element blank. Get rid of the grid. That's pretty good. Okay, so this is saying percentage of parts of this color by year, and yeah, I'm pretty fond of this visualization, even though it's a little spiky, but that's kind of natural. One thing we can really tell, a couple things we can tell. One is actually, wow, look at this. This is actually one color changing to another. We can see, wow, it's like one color replaces another. Look at this. There's one shade of light gray, and it switches to another shade of light gray around the year 2000. It's like similar happens to dark gray. You can see it's like swap around the same region of the color palette. In turn, you can kind of see red making up a smaller portion. This dark blue makes up like, wow, yeah, this is a pretty you can really imagine this is like, you know what else I like about this visualization is if you bought every single one of these sets and you stacked them within every year, this kind of would come up with that. This isn't quite what it would come up with. What it would actually come up with is this. Yeah, see, like you've got these and there wouldn't be it's not a percentage, of course, but like this is like what pieces are being used, and I like that graph, but I like this relative one even more. Yeah, so blue, like lighter blue is decreasing, this dark color is increasing. There's kind of there's greater diversity of colors. Yeah, a lot we can learn from this visualization. All right, so yeah, this is definitely my favorite. All right, so let's look at what we've come up with so far today. We read in the data using a new trick which is a trick I don't know that I've used before, which is in the screencast, was deframe to get this to do to get all the files in here and then pull out the part we want and then turn into a list. We get we looked at the sets. We looked at sets over time and kind of got oriented in the data. We looked at things like, okay, what are the most common names of sets? But then I think it really started taking off when we looked at themes and things like gears and Star Wars and the most common Lego themes. We aggregated by theme to find other themes that are more complex than others. And my favorite version of that was this box plot of number of parts based on theme. But that was really exploring like theme and number of parts. We looked a little at how it's getting more complicated over time, both overall and within one set. And the answer is, I don't think so, at least not that I can really tell. Not more complicated, not less complicated. But the most interesting part came when we joined together, for me the most interesting part, we joined together a few things so we got into the area of color. And we said, yeah, so this is the breakdown of the parts, the most common colors, and then started breaking down these like palettes by theme. So this graph I liked in terms of we can look at, okay, pick a particular theme. We can see like, all right, the Christmas has a lot of green and especially red and other colors. We even looked a little at how you can link them together, like see that Batman and the Lego Batman movie have very similar palettes. But as I said, my favorite graph we've done today, no question, is this is actually one of my favorite graphs I've done. I don't know. It's been a while, I think, since I did a screencast where I made a graph I really enjoy as much as this one for what it gets across. Really fond of this. All right, so that was today's screencast. Again, if you enjoyed yourself, please do like and subscribe. Like the video and subscribe to the feed. This will be up on GitHub, and I hope you had fun. I certainly did. I will see you next week.